Hey, welcome everybody to 9.2 Part 2. So we are now back to the front side of your worksheet, and I'm going to talk about the other format that you might get for your graphs today. And now remember, each one has a polynomial on top, a polynomial on bottom, and in this situation, because we're doing the simple ones, they're still both going to be linear. But when you divide them, that's when you get that hyperbola. Alright, so here's what you need to know for this one. The horizontal asymptote for this format is going to be the line y equals a over c. Y equals a over c. And a and c are representing the coefficients of the x. Remember, coefficient means the number in front. And it could be a 1, so watch out for that. The vertical asymptote is at the x value, which makes the denominator equal to 0. The x value which makes the denominator equal to 0. And actually, that's what we did for the other graph too. It's just because x was always by itself for this other graph, when I picked like for example A, I had x, my vertical asymptote was at x equals -3. When I put that in, it does make it 0 on bottom, but because x was by itself, that was just a shortcut saying that it was just h. So essentially what I'm saying is, to find the vertical asymptote for this one, we actually have to do some work. We have to set the bottom equal to 0 and then solve it. Let me show you what I mean with example B. Alright, so my steps are going to be the same as I did for format 1. Step 1, plot the asymptote. Step 2, find two ordered pairs on each side. So the only thing different with this format of graphing is how I find the asymptotes. So again, the horizontal asymptote is a over c. And if there's no number in front of the x, it's like a 1. So my horizontal asymptote this time is at 1/2. Then, to find the vertical asymptote, here's what I mean. I got to figure out what value will make 2x minus 4 0. So I take 2x minus 4, set it equal to 0, and solve it. And some of you might be able to do this in your head when you do these. Alright, add 4 to both sides. Divide by 2. Alright, x equals 2. And now let's just really double check. If I plug a 2 in here, will it make it 0 on bottom is the question. Yes, because 2 times 2 is 4, 4 minus 4 is 0. Okay, check. So I've got my two asymptotes, and that's the only part that's different from what we did before. Now I'm going to graph them. So x is at 2, and y is at 1/2. And you will notice when you do these graphs, you will often get decimals and fractions and things like that. The points won't always be as super nice. So I would recommend still using whole numbers for x's, so you might have to go a little further on either side to get your two values. But I'm still going to do 2 x's on the right, 2 x's on the left, and then I'm going to plug it in to find what the y value is. So on the left of this, let's see, I could do 1 and 0. So when x is 1, I'm going to take my equation and plug it in. When x is 1, here's what it looks like. And remember, I have to do the top separately and the bottom separately. So 1 plus 1 is 2. 2 minus 4 is -2. So that answer is -1. So 1 comma -1 is the first point. Next I'm going to have x is 0. So 0 plus 1, 2 times 0 minus 4. 0 plus 1 on top, 2 times 0 minus 4 on bottom. And again, I'm just every single time plugging in whatever x value it is. Alright, so now on top, 0 plus 1 is 1. 2 times 0 is 0, so 0 minus 4. So 1 -1/4. Basically 0 comma -1/4. There, that kind of makes sense. So that makes that first part of my parabola there. Sorry, I said parabola. I meant to say hyperbola. Alright, I found my 2 points to the left of the vertical asymptote. Now I need to find 2 points to the right of the vertical asymptote. Let's use x is 3 and x is 4. If you got the hang of this, you can fast forward a little bit, but I'm just going to, again, plug in the x value and solve it. So now 3 plus 1, 2 times 3 minus 4, and here 4 plus 1, 2 times 4 minus 4. I'm going to go ahead and do the top and bottom separately. 3 plus 1 is 4. 2 times 3 is 6. 6 minus 4 is 2. So it's going to be 3 comma 2. And then for my last point, 4 plus 1 is 5. 2 times 4 is 8. So 8 minus 4 is 4. So 5/4. All right. 3 comma 2 and 4 comma 5/4. That's about 1.25. That makes sense. That looks like a nice mirror. You can kind of dummy check yourself by making sure that the graph looks like it's reflected across there. And last but not least, I'm going to find my domain and range. So, domain and range, same rules apply. It's going to be all reals except where the asymptotes are. So, for my x's, all reals except my asymptote is at 2. For the y's, all reals except y is at 1/2. Pause if you need to get that written down, but when you're done, flip it over and we're going to do example D. Alright, so same step by step we did earlier. Step 1, let's find our asymptotes. Feel free to flip back to the front and look at the rules again, because I bet after one example you probably don't have them memorized yet. Hopefully you looked and you saw, okay, for the horizontal asymptote, I want a divided by c. So just the two coefficients. So y equals 1 over 3 in this situation. So my horizontal asymptote is at 1/3. Just, again, do the best you can to graph that. Alright, my vertical asymptote is whatever value makes it 0 on bottom. So I can take that and set it equal to 0 and solve it if I need to. Subtract 3 from both sides. Divide by 3. Okay, x is -1. So that means that my vertical asymptote is at -1. I'm drawing that in. There we go. Alright, and I'm going to choose then 2 points on either side of -1. So let's say maybe -2 and -3 and 0 and 1. I would like you to, on your own right now, pause and find all the y values. And let me just quick demo again. Remember, I'm just taking the equation up here, but I'm going to plug in my x value where I see x's. Everything else is as according to the formula. And don't forget, when you do this, you want to do the top together and the bottom together. Alright, then pause, and when you unpause, I will have the answer showing for this. Welcome, you have unpaused, and so you're looking at the answer here. Here's what I got. Again, if you're going to get decimals, so you're going to have to just be careful about how you squeeze that in there. For the domain, your answer should be all reals except x equals -1, and the range is all reals except y equals 1/3. Again, write down questions if you have them. There's 2 more examples here, and this is your opportunity now to see if you understand what you're doing or not for this. So this is going to be a situation for E and F. I'm going to have you pause it, unpause, and I'll show the answers, and then if you have more questions on it, we can go over these in class. But pause the video, try them, and when you unpause, I'll have the answers showing for the whole thing, including the domain and range. So find the domain and range too. See if you can do the whole problem on your own. Alright, go ahead and check your work. I'll give you a few seconds and then I'll scroll down and show domain and range. While you're looking at this, 2 things I want to comment on. First, notice example E, there was no h value, so it was a 0 then. In example F, it got really, really tight here because I had 2/3 and then 2/5 and 0 all supposed to be graphed right here. So if my graph was a little bit more exact, actually 2/3 would be a little higher, and then these would both be below that. There we go. Alright, here's our domain and range. Again, please write down your questions and we'll go over these more in class if needed. Thanks for listening.